Hello, my name is Grace Sue and I'm an undergraduate student at Columbia University. This summer, I worked on the DeepScribe project with my mentors Sanjay Krishnan, Sandra Schloen, and Miller Prosser at the Data and Computing Summer Lab. In 1933, archaeologists from the University of Chicago's Oriental Institute found tens of thousands of ancient tablets at an excavation site in Persepolis, located in modern-day Iran. The tablets were detailed administrative records of the Achaemenid Empire in Persia, which revealed information about language, society, and life at the time. For decades, researchers studied and translated these ancient documents by hand. However, this manual process is very laborious, slow, and prone to errors. Thus, the DeepScribe research project was created to address this problem. DeepScribe is a tool that automatically deciphers cuneiform using computer vision, freeing researchers up for higher-level analysis. With a training set of more than 6,000 annotated images of Elamite cuneiform tablets, this research project aims to build a computer vision model that can read currently unanalyzed tablets. This ample source of training data comes from the Oriental Institute's Persepolis Fortification Archive project, which has digitally photographed the previously mentioned tablets and stored their information on the online cultural and historical research environment, also known as the OCHRE data service. So this summer, when I joined the DeepScribe project, I helped investigate why the computer vision model was incorrectly classifying signs and how to improve it. The model, as its training data, takes images of individual signs which have been highlighted from tablets and annotated by cuneiform experts as hotspots on the OCHRE data service. Then, when the model is given a new image of a sign, it can predict the sign's name. My mentors and I investigated how applying different image processing and machine learning techniques affected the model's accuracy. As a result of this summer's work, I helped find and fix errors in the image dataset. I also developed a Python module to establish a basis for DeepScribe as a tool that can be used by other researchers. This combined the computer vision pipeline code for loading images and their corresponding signs, pre-processing the images, and building a convolutional neural network into one module. I additionally performed several experiments to vary different details of the model's convolutional neural network and analyzed the results. I discovered which specific operations were helpful and kept them, and eliminated ones that were not. Interestingly, we learned that a simpler MNIST model architecture, which can read handwritten numbers well, does not work well for our dataset. Feature extraction with a pre-trained model and classification performed just as poorly. A relatively more complex ResNet architecture model performed better instead. Also, data augmentation by shifting the image along its width and height by up to a proportion of 0.2 helped increase the accuracy by about 10%. Additionally, the skew in the dataset, where there are signs with very few image examples, while the skew is severe, it had actually almost no effect on model accuracy, so something else may be causing misclassifications of signs. In the future, this project will hopefully give us new and exciting insights into computer vision, such as how computer vision can interpret 3D symbols from 2D images, what features different script recognition models might have in common, and how a computer vision model might be generalized to be able to interpret different kinds of writings at once. We ultimately envision DeepScribe to become a general-purpose tool that can receive an image of a cuneiform artifact from a user, detect and hotspot the locations of signs, predict labels for the signs, and suggest readings for the signs based on textual context, therefore enhancing the archaeological research workflow.